evaluate the following integrals. So we got two of them here. Sine to the fourth theta, cosine theta, d theta. So sine to the fourth theta is basically sine theta raised to 4 times cosine theta. This is a product of two functions. Here we got sine theta fourth, 4 power sine 4 theta, cosine theta. Since there is a product, we don't have a product rule, and one got something inside parenthesis. So we can use a u substitution. Let's use substitution. So for that, our u is inside function, so we let u be sine theta, because this is sine theta to the fourth, and we want to simplify more complicated terms. So sine theta, so we want to convert the whole integral in terms of new variable u. So we need to convert d theta as well. For we take the derivative of both sides. So derivative of cosine theta, sine theta is, it's the cosine theta. Isolate d theta, so cosine theta to the left equals d theta. Okay, with this substitution, this integral becomes sine theta to the fourth. We said sine theta be u, so u to the fourth. We don't know about cosine theta for now. D theta, we found d theta here, which is du over cosine theta. Now you can see this cosine theta on the top and bottom cancel. So this cosine theta was here for our help. So this is simply u to the fourth du now. Using the power rule like x and dx, the integral of u4 with respect to u is u4 plus 1, 5 over 5 plus c. We are done. All we have to do is back substitute u. So this is, we can write in terms of coefficients. So 1/5 we can write in the front, 1/5 u to the 5. U happens to be sine theta, so sine theta power 5, which is sine 5th theta plus c. That's the final answer. Now we got similar question here. Sine theta times square root of 1 plus cosine theta. This is also a product, and we cannot simplify. There is no product rule, so we must use u sub, and which is possible because we have something inside this radical sign. So we let u be 1 plus cosine t. Okay, this becomes square root of u. To convert dt in terms of du, because we want to convert everything in terms of new variable u, so we need to find derivative. Du over dt, the variable is t, so du over dt 0 plus derivative of cosine is negative sine. Now we isolate dt, move that to the other side. Du over negative sine t equals dt. Now this integral becomes sine t. We have no information, but this one is, by our assumption, square root of u. And now dt is here, du over negative sine t. And we can see this sine t cancelling like last time. Then negative can be pulled outside. This is negative 1, just negative 1. Square root of u du. Square root of u means u square root 1/2, u raised to 1/2 du. Now we use the power rule, minus, it's like x and dx. Xn plus 1 means 1/2 plus 1. 1/2 plus 1 is 3/2, and divided by same thing, 3/2 plus c. Okay, this is a complex fraction because we are dividing by a fraction. So this 3/2 becomes 2/3 when we keep change flip. So negative, this is 2/3 Okay, u raised to 3 halves, you need to back substitute u. U is in fact 1 plus cosine t. 1 plus cosine t raised to 3 halves. Okay, plus c. That's final.